Hey guys, today we are going to read Class 10 Geography, Resources and Development Part 2, Land Degradation and Conservation Measures. We have shared our land with the past generations and will have to do so with future generations too. 95% of our basic needs for food, shelter, and clothing are obtained from land. Human activities have not only brought about degradation of land, but have also aggravated the pace of natural forces to cause damage to land. Some human activities such as deforestation, overgrazing, mining, and quarrying too have contributed significantly in land degradation. Mining sites are abandoned after excavation work is complete, leaving deep scars and traces of overburdening. In states like Jharkhand, Chhattisgarh, Madhya Pradesh, and Odisha, deforestation due to mining have caused severe land degradation. In states like Gujarat, Rajasthan, Madhya Pradesh, and Maharashtra, overgrazing is one of the main reasons for land degradation. In the states of Punjab, Haryana, western Uttar Pradesh, over-irrigation is responsible for land degradation due to waterlogging, leading to increase in salinity and alkalinity in the soil. The mental processing like grinding of limestone for cement industry and calcite and soapstone for ceramic industry generate huge quantity of dust in the atmosphere. It retards the process of infiltration of water into the soil after it settles down on the land. In recent years, industrial influence as waste have become a major source of land and water pollution in many parts of the country. There are many ways to solve the problems of land degradation. Afforestation and proper management of grazing can help to some extent. Planting of shelter belts of plants, control on overgrazing, stabilization of sand dunes by growing thorny bushes are some of the methods to check land degradation in arid areas. Proper management of wastelands, control of mining activities, proper discharge and disposal of industrial effluents and wastes after treatment can reduce land and water degradation in industrial and suburban areas. Soil as a resource. Soil is the most important renewable natural resource. It is the medium of plant growth and supports different types of living organisms on Earth. The soil is a living system. It takes millions of years to form soil up to a few centimeters in depth. Relief, parent rock, bedrock, climate, vegetation, and other forms of life and time are important factors in the formation of life. Various forces of nature such as change in temperature, actions of running water, wind and glaciers, activities of decomposers, etc. contribute to the formation of soil. Chemical and organic changes which take place in the soil are equally important. Soil also consists of organic humus and inorganic materials on the basis of factors responsible for soil formation: color, thickness, texture, age, chemical and physical properties. The soils of India are classified in different types. Classification of soil. India has varied relief features, landforms, climatic regions, and vegetation types. These have contributed in the development of various types of soil. Alluvial soils. This is the most widely spread and important soil. In fact, the entire northern plains are made of alluvial soil. These have been deposited by three important Himalayan river systems: the Indus, the Ganga, and the Brahmaputra. These soils also extend in Rajasthan and Gujarat through a narrow corridor. Alluvial soil is also found in the eastern coastal plains, particularly in the deltas of Mahanadi, Godavari, the Krishna, and the Kaveri rivers. The alluvial soil consists of various proportions of sand, silt, and clay. As we move inland towards the river valleys, soil particles appear somewhat bigger in size. In the upper reaches of the river valley, that is near the place of the break of the slope, the soils are coarse. Such soils are more common in piedmont plains such as Duars, Kos, and Terai. Apart from the size of their grains or components, soils are also described on the basis of their age. According to their age, alluvial soils can be classified as old alluvial bungar and new alluvial khadar. The bungar soil has higher concentration of kankar and nodules than the khadar. It has more fine particles and is more fertile than the bungar. Alluvial soils as a whole are very fertile. Mostly these soils contain adequate proportion of potash, phosphoric acid, and lime, which are ideal for the growth of sugarcane, paddy, wheat, and other cereal and pulse crops. Due to its fertility, regions of alluvial soils are intensively cultivated and densely populated. Soils in the drier areas are more alkaline and can be productive after proper treatment and irrigation. Black soil. These soils are black in color and are also known as redwood soils. Black soil is ideal for growing cotton and is also known as black cotton soil. It is believed that climatic conditions along with the parent rock material are the important factors for the formation of black soil. This type of soil is typical of the Deccan basalt region, spread over northwest Deccan Plateau, and is made up of lava flows. They cover the plateaus of Maharashtra, Saurashtra, Malwa, Madhya Pradesh, and Chhattisgarh, and extend in the southeast direction along the Godavari and the Krishna valleys. The black soils are made up of extremely fine, that is, clay material. They are well known for their capacity to hold moisture. In addition, they are rich in soil nutrients such as calcium carbonate, magnesium, potash, and lime. These These soils are generally poor in phosphoric contents. They develop deep cracks during hot weather, which help in the proper aeration of the soil. These soils are sticky when wet and difficult to work on unless tilled immediately after the first shower or during the pre-monsoon period. Red and yellow soils. Red soil develops on crystalline igneous rocks in areas of low rainfall in the eastern and southern parts of the Deccan Plateau. Yellow and red soils are also found in parts of Odisha, Chhattisgarh, southern parts of the Middle Ganga plain, and along the Piedmont zone of Western Ghats. These soils develop a reddish color due to diffusion of iron in crystalline and metamorphic rocks. It looks yellow when it occurs in a hydrated form. Laterite soil. Laterite has been derived from the Latin word later, which means brick. The laterite soil develops under tropical and subtropical climate with alternate wet and dry season. This soil is the result of intense leaching due to heavy rain. Lateritic soils are mostly deep to very deep, acidic pH less than pH more than 6.0, generally deficient in plant nutrients and occur mostly in southern states, Western Ghats region of Maharashtra, Odisha, some parts of West Bengal and northeast regions where these soils support deciduous and evergreen forests. It is humus rich, but under sparse vegetation and in semi-arid environment, it is generally humus poor. They are prone to erosion and degradation due to their position on the landscape. After adopting appropriate soil conservation techniques, particularly in the hilly areas of Karnataka, Kerala, and Tamil Nadu, the soil is very useful for growing tea and coffee. Red laterite soils in Tamil Nadu, Andhra Pradesh, and Kerala are more suitable for crops like cashew. Arid soils. Arid soils range from red to brown in color. They are generally sandy in texture and saline in nature. In some areas, the salt content is very high, and common salt is obtained by evaporating the water. Due to the dry climate, high temperature, evaporation is faster, and the soil lacks humus and moisture. The lower horizons of the soil are occupied by conker. Because of the increasing calcium content downwards, the conker layer formations in the bottom horizons restrict the infiltration of water. After proper irrigation, these soils become cultivable, as has been in the case of Western Rajasthan. Forest soil. These soils are found in the hilly and mountainous areas where sufficient rainforests are available. The soil's texture varies according to the mountain environment where they are found. They are loamy and silty in valley sides and coarse-grained in the upper slopes. In the snow-covered areas of Himalayas, these soils experience denudation and are acidic with low humus content. The soils found in the lower parts of the valleys, particularly on the river terraces and alluvial plains, are fertile. Soil erosion and soil conservation. The denudation of the soil cover and subsequent washing down is described as soil erosion. The processes of soil formation and erosion go on simultaneously, and generally there is a balance between the two. Sometimes this balance is disturbed due to human activities like deforestation, overgrazing, construction, and mining, etc. While natural forces like wind, glacier, and water led to soil erosion, the running water cuts through the clay soil and makes deep channels as gullies. The land becomes unfit for cultivation and is known as bad land. In the Chambal Basin, such lands are called ravines. Sometimes water flows as a sheet over large areas down a slope. In such cases, the topsoil is washed away. This is known as sheet erosion. Wind blows loose soil off flat or sloping land known as wind erosion. Soil erosion is also caused due to defective methods of farming. Plowing in a wrong way, that is, up and down the slope form channels for the quick flow of water leading to soil erosion. Flowing along the contour lines can decelerate the flow of water down the slopes. This is called counter plugging. Steps can be cut out on the slopes, making terraces. Terrace cultivation restricts erosion. Western and central Himalayas have well developed terrace farming. Large fields can be divided into strips. Strips of grass are left to grow between the crops. This breaks up the force of the wind. This method is known as strip cropping. Planting lines of trees to create shelter also works in a similar way. Rows of such trees are called shelter belts. These central belts have contributed significantly to the stabilization of sand dunes and in stabilizing the desert in western India. With this, we have ended our chapter. Thank you.